Okay, let's get into Glencoe Algebra 2, Section 1-5, Solving Inequalities. As I mentioned in our video for Section 1-4, we're going to be doing a lot of taking what we learned in Section 1-3 about solving equations and applying it to new types of equations or new types of mathematical sentences. And so here's our second example of this. In Section 1-4, we saw taking that lesson from 1-3 about solving equations and applying it to equations that contain absolute value functions in them. And now what we're going to do is we're going to look at equations that are actually called inequalities. And we're going to look at how to use those same principles with some minor tweaks to help us solve inequalities. So let's first define inequality. If things are equal, that means they are the same. So when we hear the term unequal or inequality, we would think that they're not the same. Putting the prefix in front of a word usually means the opposite of. We hear this all the time in football. Announcers use it. The pass was complete or it was incomplete, meaning not complete. It's kind of like the word not right there in front. So not equal. Now, that's not to say that we're going to be working with things that are not necessarily equal. I don't want you to think about it like that. I want to think about inequalities as being different from equations in that the solutions, and please note that I said solutions with an S at the end, there are many solutions. And that's kind of the point of what we're doing, is that there are many solutions to these. When you solve an equation, just a regular old equation, there's only one solution. And when you solve an inequality, like we're going to do today, inequality, there are many solutions. And we need to represent all of them. And the solutions that we're going to find need to fit a certain criteria. And that criteria is going to be located over here in this box, because we're going to be looking for the set of values that make the number sentence greater than a certain value, less than a certain value, greater than or less than or equal to a certain value. So we're going to use these symbols in place of an equal sign when solving inequalities. And we're going to start by solving inequalities when you need to add or subtract in order to solve them. And that would be something that might look like this. 6 plus x is greater than 9. I just made that up. And this is a pretty basic thing to solve. And so what we're going to do here when we're solving with addition or subtraction, notice that there's addition right here. There's no multiplication. There's no division. The only operation that shows up in here is addition. There's a very simple way to solve that. And so when you're solving with addition or subtraction, you're going to, I'm going to write just solve it. Okay? Just solve it. In fact, I'm even going to write here, pretend it's an equal sign. That's it. You're going to pretend that this symbol right here is just an equal sign, and you're going to solve it as if it says 6 plus x equals 9. And if you do that, I mean, obviously you need to make sure and carry the greater than sign through the problem, but we're just going to solve it. You're just going to solve it. You're going to follow straight through with that greater than sign in there, and that's going to give us our answer. The one other thing that we're going to have to do with these answers, as you're going to see in example 1, is we're also going to graph them. We're going to put all of the solutions on a number line so we have a visual representation of what all of these many solutions look like. So let's get to example 1, which is going to, again, focus on solving when addition and subtraction are involved. And all we're going to do is pretend that there is an equal sign in our inequality instead of our greater than or less than symbol. So here's example 1. Notice the directions say solve an inequality using addition or subtraction. And it says graph the solution set on a number line. Okay, so there's a little tip there for the graphing part on the right side, right over here. We're going to ignore that for now. We'll come back to it when we get to the graphing part. For now, I want to solve this. Y minus 6 is less than 3. So the values that I'm looking for y are values of y that will make the left side be less than 3. So that could be many numbers. Many numbers, when substituted for y, will make the left side less than 3. And that's what I'm looking for. I'm looking for all of those values. And so, as I stated on the last screen, since we have just addition or subtraction here, we're just going to go ahead and solve this and pretend it's an equal sign. So as we've done in the past, y minus 6 is less than 3. Just to rewrite it there. The only math that I see in here is subtraction of 6. And we know that in order to get y by itself, we're going to add 6 to both sides. We need to do the inverse. We need to do the opposite. So I'm going to add 6 on this side, which makes this become 0 and leaves y all by itself. And I'm going to add 6 over here, and 3 plus 6 is equal to 9. And in between these, I'm going to keep my less than sign. So y less than 9. Now what does that mean? Y is isolated. We're done solving this. There's no other math to take care of. So we have an expression that says y is less than 9. So this is our final answer. Y is less than 9 is important. And the last thing that it says to do is it says graph the solution set on a number line. And so I'm going to look over here at my study tip. And it says when you're graphing inequalities, a circle is used for less than and greater than, and a dot is used for less than or equal to and greater than or equal to. So that just tells me that when I actually put my number line together and I put my solution on the number line, that I'm going to go ahead and I'm going to use an open circle instead of a dot. And what that says is that the value 9 is not okay. Not a solution. Okay, so the value 9 right there is not a solution. What is a solution is any y value that's less than 9. Okay, so I'm going to go ahead and make my number line. Big line across the bottom here. I'll put 0 right over here. We'll do like 2, 4, 6, 8, 10. I'll throw some labels there. 2, 4, 6, 8, 10. And so now I need to put all the y's that are less than 9. And so again, the way we're going to do this is since it's less than, when we graph this, we're going to use an open circle. So I'm going to go to 9. 9 is right here in between 8 and 10. Halfway between 8 and 10 is 9. I'm going to put an open circle right there. Big open circle for emphasis. Some people like to put it right at the top, put it just above 9 so that you're not on top of your number line. It's easier to see, especially on your papers in class or on a test. You might want to do that so that your if you have to draw your own number line, your pencil or pen, since they're going to be the same utensil you're using, might not show up. And now we need to draw an arrow to show that we want all of the values that are less than 9. Well, values that are less than 9 are on our number line are to the left of 9. So that means that I'm going to draw my arrow in this direction, right? Or like this. And what we're looking at here is we're stating that every single number on our number line that is less than 9 will be a good solution to this inequality. Now that means, now when I say less than 9, it only has to be a little bit less than 9 in order to work. Meaning like 8.9999999 will work, or 8.75, or 8, or 6, or 4, or 2, or 0, or negative 100. Any number that is less than 9 will work. If you put 9.0 in there, it will not work. Like I said, 8.99999 is okay. It's less than 9. So we're looking for only values that are less than 9. And since this circle is here, since I used a circle in order to show where to start on the number line, that means that 9 is not a good solution. It is not okay to use 9 as my y value when trying to solve this inequality. Let's move over here. Here are the guided practice for example 1. There are 2 of them here. You're going to, again, this is just addition and subtraction, so we're just solving this as if it's got an equal sign there. I'm just going to pretend it's an equal sign, and you're going to solve it just like you normally would. You're going to move things around, combine like terms, isolate the variable, either w for 1a or x for 1b. Go ahead, pause this video now, give them a try. The guided practice answers including the graphs. Don't forget to graph your solution. The graphs and the values will show up at the end of this video. Okay, now that you've tried those, let's move on. The next logical question is, well, if we've covered solving when we have addition and subtraction involved, what happens with multiplication and division? Is it different? Why wasn't that presented at the same time? And there's a good reason for that. And the answer to this question falls into 2 categories. So the first category, and the 2 categories are pretty simple. One is it a positive value that you are multiplying or dividing by? And the other category is it a negative value? Okay, so if we're in a situation where we have a positive value, what we're going to do is we're going to do the same thing we did before, and we're going to pretend it's an equal symbol instead of greater than or less than, and we're just going to do it. Just solve it. Do nothing different. Carry your greater than, less than, greater than equal to, less than equal to symbol all the way through the problem while pretending that it's just an equal sign, and just solve it. Don't do anything differently. It's no big deal. If you are multiplying or dividing by a positive value to solve an inequality, you don't do anything different. No big deal at all. If the value that you are dividing by or multiplying by is negative, now we have to do something different. At the moment that you multiply or divide by a negative value, you have to flip the inequality symbol. Okay. Multiplying or dividing by a negative value in an inequality means we have to flip our inequality around, meaning that if it already says less than, you have to change it to greater than, and if it says greater than, you have to flip it to less than. And that goes the same for whether they are equal to or not. But in any case, if you divide or multiply by a negative value during the course of solving a problem, you have to remember to flip the inequality symbol. You can't just leave it alone this time. It's the only time that we're going to mess with our inequality is if it's negative value that we're multiplying or dividing by when solving. So let's move over and take a look at a couple examples. Okay, here it is, example 2. Solve an inequality using multiplication or division. Okay, so again, it says to graph our solution. So I put the little reminder here for when you're graphing about whether you use a circle or a dot. In this problem, it does say that negative 4.2x is less than or equal to. So that means that in this problem, when we make our graph, we're going to use a dot instead of an open circle. This is also the point in the book where they introduce what's called set builder notation. And that's something that you do need to be aware of. You will see it in the book or potentially on a test in the future. So I do want to discuss that very quickly. It really shouldn't be that complicated, but I do want to mention it. But let's dive into solving this. Again, I'm going to rewrite it. Negative 4.2 times x is less than or equal to negative 29.4. Okay, so I only see one mathematical operation here. When I wrote the problem as I spoke, the only thing I said was times. Negative 4.2 times x. So we have multiplication here. And in order to fix this, in order to isolate x like we always want to do, I have to undo that multiplication, and the opposite of multiplication is division. So I'm going to divide on both sides by negative 4.2. Now notice what I just said. I'm going to divide by negative 4.2, and that's the point of this example, is for us to remember that what we just talked about is if we multiply or divide by a negative value on both sides, like we're doing right now, we have to flip our inequality around. So negative 4.2 divided by negative 4.2 becomes positive 1, and we're left with just 1x. 1x on the left. And since I'm dividing by a negative value, I'm going to take my less than or equal to symbol located in the middle of my problem, and I'm going to flip it around and make it greater than or equal to. Okay? So I flipped it. Notice, up in this level, it said less than or equal to. Down here, it says greater than or equal to. So we actually flipped it around from one to the other. Now if I get a calculator and I do negative 29.4 divided by negative 4.2, I find out that x is greater than or equal to 7. Okay, so I now have an answer. X is greater than or equal to 7. I still need to graph it, and I want to rewrite this answer in set builder notation. Now, rewriting the answer in set builder notation is really not that difficult. Essentially, all set builder notation is, it's a squiggly bracket, I'm not going to actually make the bracket, but squiggly bracket, and then the variable that you're using, x, and then a vertical line, and then the answer that I just circled, x greater than or equal to 7, and then we have to close our squiggly bracket. That's set builder notation. And if we look down here where it says reading math, it tells us how to say that. Okay, so it says we read this as the set of all numbers x. Okay, so the set of all numbers x such that x is greater than or equal to 7. So it's a good idea for you to know how to say that and to know what that means. Don't at any point want anybody to see something written in set builder notation and not be able to come up with the idea that this is the answer. Okay, this is just as good. It's just a little bit more of an official math way to write the answer. So you do need to be familiar with that in case it shows up somewhere in the future. But now we need to graph our solution. So we have our answer written in set builder notation over here on the right. And now we need to graph it. So I need to graph and show that the solution to this inequality is every single x that is greater than or equal to 7. So I'm going to set my number line up. Put my line across the bottom here. Put 0 right down here. I like 2, 4, 6, 8, 10. I'm going to go ahead and put the graph of the solution above the number line in this case. It does have equal to in it. This says greater than or equal to. So again, like we stated earlier, I'm going to use a dot. So a filled in dot at the value 7. 7 is located between 6 and 8. So I'm going to put a dot right here. Solid filled in dot. And I want to choose to make an arrow in the direction that shows every value that's greater than 7. So the filled in dot says that 7 is okay. 6.99 is not okay. 7 is okay. 7.0 is a good value. And any value on this side to the right of that dot is a good answer. 10's okay. 7.00001 is okay. 8 is okay. 50's okay. 100 is okay. 1,000,000 is okay. Any value located to the right of the number 7 on my number line will make this inequality true. It will make the left side less than or equal to negative 29.4 if I plug an appropriate x value into that equation. If we move over, here's 2 guided practice problems for you to try. Pause the video now. Answers will appear at the end of the video. Okay, so move on to example 3. Excuse me, example 3. You'll notice it says solve multi-step inequalities. So this is the point where we start to put it all together. If you remember from section 1-3, and again, this is very much like solving equations like we learned in 1-3. We did one-step equations where all you had to do was add or subtract. We did we solved one-step equations where all you had to do was multiply or divide, and then we started to solve multi-step equations. And that's what we're going to do here. These are going to involve more than one possible step, combining like terms, adding, subtracting, multiplying, dividing, any combination of these things. And what we need to remember is that as long as we're not multiplying or dividing by a negative value, all we're doing is solving it. Just solve it. That's it. If we need to divide or multiply by a negative value, then we have to remember to flip our inequality. That's it. We also need to remember to use set builder notation, and we have to remember that we're asked to graph our solution set on a graph. So let's go ahead and start this one here. It says solve negative 4c is less than or equal to 5c plus 58 divided by 6. So we want to know what c values can we plug in both of these locations and have this relationship happen, that the left side will be less than or equal to the right side. So let's go ahead and rewrite it. Negative 4c less than or equal to 5c plus 58 divided by 6. Okay, so the first step that I'm going to use in solving this is, I don't like that right side is on top of 6. I don't like that there's division there. So I'm going to undo that division first by multiplying both sides by 6. And I'm multiplying by positive 6, so I don't have to do anything special. I don't have to flip my inequality symbol or anything like that. I'm simply going to multiply by 6 on this side and multiply this whole side by 6 also. So these 6's will cancel each other out, or 6 divided by 6 is just 1. And on the left side we have 6 times negative 4c, which is negative 24c. I'm going to keep less than or equal to without flipping it, because all I did was multiply by a positive value. And then I'm left with 5c plus 58 on the right hand side. So now I have something that looks a little simpler. What I'm seeing here is that I'm going to want to get my 5c's and my negative 24c's on the same side together somehow. So I'm going to have to figure out how to do that so I can combine like terms. Okay, so if I look at this as positive 5c plus 58, then what I'm going to do is I'm going to say, well, positive 5c, the opposite of plus 5c is minus 5c. So if I subtract 5c on this side, it will go away. 5c minus 5c is 0, and that will leave me with 58 all by itself on the right. And then I'm going to need to subtract 5c's on the other side, minus 5c. Negative 24c minus 5c is negative 29c. And I'm going to keep my inequality symbol the same, less than or equal to, because I subtracted there. There was no multiplying or dividing by a negative value. That was simply subtraction. So I don't flip the inequality. And now I have a situation where I got to get that c by itself. And there's one more step left. That says negative 29 times c. So in order to undo that multiplication, I need to divide on both sides by negative 29. And again, I said negative 29. So dividing by a negative value means that I need to flip my inequality. So negative 29 divided by negative 25 is positive 1c. I'm going to flip my less than or equal to a greater than or equal to. And 58 divided by negative 29 is equal to negative 2. So I have an answer that looks like c's, good c's, are c's that are greater than or equal to negative 2. So let's start by putting that in set builder notation. We remember I'm going to do squiggly line, c. Okay, so that's the set of all c's. and I like to write it and say it at the same time, such that, I kind of pretend that vertical line is the word words such that phrase, such that C is greater than or equal to -2, and I close it off. And that just tells me that all of the C's that will work are the C's that are greater than or equal to -2. And so I want to put that on my number line, which I have down below here. This number line's already pre-set up pretty nicely. And I want to find -2. -2 is located right here. So above my -2, I need to indicate that that's where I start. And in this case, I'm going to start with a dot, a filled in dot, not a circle, because it does say greater than or equal to. And so that equal to part tells me to fill it in. So greater than or equal to, things that are greater than -2 are found to the right. So I'm going to take my arrow here and I'm going to draw it in this direction. And that tells me that my graph should have the dot above the -2. The graph tells me that anything to the right of -2 is a good solution. And I could go back and check these, and I could plug in 0 into both of these places, and it would work. It would satisfy the equation. If I were to substitute in -2.01, it would not work. -2.01 is less than -2, and therefore not a good solution. Anything greater than -2 is a good solution, including -2 in this case. On the next screen, there are actually 4 of these for you to try. So let's go ahead, try these guided practice, pause the video, and at the end, again, the number lines and the solutions will be given to you. Okay, moving on to example 4. Example 4 here is the real world example that they try to do one of those every chapter. This example, it says write and solve an inequality. So it's actually asking you to take the information that you're given in the problem and write an inequality that you can solve to find the answer. And this is a very good example to use, and it's something that you may encounter one day, or maybe you know somebody who has encountered something like this or has a job that works like this. Many people work off of commission, and that means that the amount that you get paid is based on how much work that you do or how much business you bring in. And that's kind of like what's going on here with Enrique and Salim. It says Enrique's company pays Salim to advertise on Salim's website. Salim's website earns $15 per month automatically, plus 5 cents every time a visitor clicks on the advertisement. So Salim gets paid $15 just for having the ad up there, and then the more people that click on the ad on his website, the more money he makes. And so this question that's going to be asked is kind of like, well, if I want to make sure that I'm making this much money, how many people need to click? It says, what is the least number of clicks per month that Salim needs in order to earn $50 per month or more? So we want to earn $50 or more, $50 being the lowest. So we're kind of looking for the lowest number of clicks that need to happen, in addition to getting paid that $15 automatically. So the understand section here says let C equal the number of clicks on the advertisement. He earns $15 per month and 5 cents per click, and he wants to earn a minimum of $50 for the advertisement. And then the plan is to write the inequality. So they look at the words first. The monthly income is 15 plus 0.05 cents, 5 cents per click, and the total should be at least $50. So they're going to use the variable C to represent the clicks, and then the inequality looks like this. We have a flat fee of $15 plus 0.05C. Now, 0.05C, that's multiplication. Okay, so if you get clicked 100 times, then you get 5 cents 100 times. And that's why we're using multiplication there. 0.05 per click. For every 1 click, he gets 5 cents. And then this is the part that I think is the important part. It says is at least. Okay, is at least, and they're going to use greater than or equal to. Remember up here it says he wants to earn $50 per month or more. Okay, so we want to equal $50, which is how we determine whether or not we're going to use greater than or equal to. Greater than or equal to because we want to earn $50. $50 is an okay amount for us to earn, or more. And so we want our $15 flat fee plus our 5 cents per click to be greater than $50. Okay, we want to keep it greater than $50. And then we need to solve that. So we've written the equation out here again. 15 plus 0.05c is greater than or equal to 50. And we got to keep all of our rules in mind. And for this question, we're just looking for the value. We're not looking for set builder notation. We're looking for kind of what is that minimum number of clicks. So some number or more clicks will do the job. And we don't need to graph it because it's just asking us to find the value. So let's go ahead and see here. 15 plus 0.05c is greater than or equal to 50. So there's a couple steps here. I see addition and I see multiplication. And so as we've learned in section 1-3, we're going to do SAD MEP. So we're going to kind of work backwards from the traditional please excuse my dear Aunt Sally. And we're going to start with subtraction and addition. So since there's addition of 15 here, I need to undo that first. And I'm going to undo that by subtracting 15 on both sides. Minus 15. So 15 minus 15 is 0, and I'm left with 0.05c is greater than or equal to 50 minus 15 is 35. So 0.05c is greater than or equal to 35. I did not flip my inequality symbol because I did not multiply or divide by a negative value. I do need to multiply or divide in order to finish this problem because I see multiplication here. I have c multiplied by 0.05. And to undo multiplication, I need to divide. So I'm going to do 0.05. Now 0.05 is positive. 0.05 divided by 0.05 is just 1. I'm left with c. I do not need to change the direction of my inequality, and I'm going to divide by 0.05 on this side. And if I get my calculator, 35 divided by 0.05 is equal to 700. So 700 clicks will do the job. If people visit Salim's website and click on the ad 700 times a month, then he will earn the $50 he wants. Any number of clicks greater than 700. So clicks C need to be greater than or equal to 700 in order to earn up to $50. There's an example for you to try. Here it is about Rose's cell phone bill. Pretty common theme these days. Pause the video, give this one a try. Okay. Here are the guided practice answers. Notice that each one is given as a value. W, for example, 1a. W is greater than 6, and then it is given on a number line as well. All of these are graphed. Notice that they have open circles when the value is greater than or less than. They have closed dots when the value is greater than or equal to or less than or equal to. And number 4, Rosa, she can use 80 minutes past her free minutes and still pay less than $70. So she can stay within budget if she stays under 80 extra minutes past her free minutes. As always, connected.mcgraw-hill.com is the website you can visit to sign in and get 24/7 book access. Today we talked about section 1-5, which is located on pages 33 to 36, and your homework is on the next screen. Here's the Check Your Understanding section. Please try these 9 problems and come prepared to check your answers first thing when you get to class tomorrow. I also like to point out here, in case you haven't noticed, that the Check Your Understanding section does sometimes include this green dot that says step-by-step solutions begin on page R14. Number 7 here, if you go to page R14, is worked out for you step by step. You can see the whole solution, just like it's an example problem that's worked out in the book. So keep that in mind as you're doing work in the book. If you see those green dots, you can go there to get a little bit of extra help. See you tomorrow.